Hi there, this is Estelle Trengove and this is my short video for LN 2017 on doing mesh analysis using supermeshes. You get a supermesh when two meshes next to each other share a common branch that contains a current source. In this circuit there are three meshes. Let's define mesh current. So we'll define a mesh current here called Y1, a mesh current here called Y2, and a mesh current here called Y3. Remember that in mesh analysis, we apply Kirchhoff's voltage law around each mesh, and then we express each voltage in terms of mesh currents and resistances. So if you look at this circuit, the mesh 1 and mesh 2 have a shared branch, and that shared branch has got a 2 amp source in it. So if you go around this loop here, that's a voltage. You can put it in your Kirchhoff's voltage law equation. This you can express as a voltage in terms of the mesh current and the resistance. But over here we have a problem because we don't know what the resistance is of the current source, and an ideal current source has a zero resistance. So we are going to define a supermesh over here, and that supermesh is going to contain the two meshes that have the shared current source in their common branch. And then we are going to write down Kirchhoff's voltage law around the supermesh. So starting at this point and working our way around the supermesh in this direction, around the supermesh by Kirchhoff's voltage law, we have minus 6 volts plus 10 ohms times Y1 plus 6 ohms times Y2 minus Y3. And that all must be equal to 0. So we're still using the original mesh currents that we defined, Y1, Y2, and Y3, but we're just writing down Kirchhoff's voltage law around the supermesh. So if you gather like terms in this equation, we get 10 Y1 plus 6y2 minus 6y3 is equal to 6 volts. And that's the first equation that we need to solve for all the unknown mesh currents in the circuit. And now for mesh 3 by Kirchhoff's voltage law, going around mesh 3, we've got 2 ohms times y3 plus 4 volts plus 6 ohms times y3 minus y2, and that all must be equal to 0. And so if we gather like terms, then we get minus 6y2 plus 12y3 is equal to minus 4 volts. And that's the second equation that we need to solve for all the unknown mesh currents. And now you can see we have two equations, but we have three unknowns. We've got y1, y2, and y3, and we need three simultaneous equations if we want to solve for three unknowns. So if you look at the supermesh, you'll see that in the branch where the 2 amp source is, you can see we've got current Y1 flowing in this direction and current Y2 flowing in this direction. So we can say that Y1 minus Y2 is equal to 2 amps. And that gives us our third equation, and now we can solve for all the branch currents. That's the end of this recording.